In the second video of this polynomials, we will be learning something more about polynomials. Let's learn about degree of a polynomial. What do you mean by degree of a polynomial? Degree of a polynomial is nothing but the highest power of the variable occurring in the given polynomial. That means the highest power of the variable that will exist in the given polynomial. Now, for example, if you take the first one, 2x cubed plus 5x squared minus 3x minus 7. So here, if we look at each term, you can see that the powers are 3, 2, 1, x power 0. So here, the highest power, what would be the highest power? The highest power here is 3. So degree of this polynomial would be considered as 3. Similarly, in the second example, we have 2x power 4 plus 5x minus 7. So here we can see first term the power is 4, second term power 1, third term power 0. So here, since the highest power is 4, degree will be 4. The third expression, this is not as we studied earlier in the previous video. This is not in the standard form of a naught x power n plus a1 x power n minus 1, where all the terms are written independently. So we'll have to do some steps here, that is maybe multiply. So that is going to be x into 2x cubed minus 3 plus 1 into 2x cubed minus 3. So that means only after we convert the polynomial in the standard form, we can we can identify the degree. So this is in the standard form of a polynomial after multiplying. That is 2x cubed into x is 2x power 4 minus 3x plus 2x cubed minus 3. So here we can clearly see that the highest power here is 4. So that means the degree of this polynomial will be 4. Now, keeping in mind the degree, we'll move on to the next topic, that is types of polynomials. Now, depending on the degree, the polynomials are named. That is, for example, linear polynomial. So linear represents 1. So whenever the degree of a given polynomial is 1, that polynomial will be called as a linear polynomial. That is, for example, a polynomial in a variable x. If you want to write a linear polynomial x plus 4, since here the highest power is 1, degree is 1. So this can be example of a linear polynomial. Some more examples: y plus 3 z. So these are all polynomials of degree 1. So this will be all considered as linear polynomials. Then we go to quadratic polynomials. So quadratic, whenever the degree is 2, whenever the degree of the polynomial is 2, then that polynomial will be considered as a quadratic polynomial. Examples: x squared plus 2x plus 3, y squared plus 3, z squared minus 4, and etc. Cubic polynomial. A polynomial whose degree would be 3 would be considered as a cubic polynomial. Example: x cubed plus 3, x cubed plus 2x squared plus x, and so on. Then we have biquadratic polynomial when the degree is 4. That is, whenever the degree highest power in the given polynomial is 4, that polynomial can be considered as a biquadratic polynomial. For example, x power 4 minus 2x, y power 4 plus 3x cubed plus 3y cubed plus 2. So here in both the polynomials, the highest power is 4, so that these polynomials can be considered as biquadratic polynomials. We also have one more polynomial, that is like constants. For example, if I have to write a polynomial in the variable x, p of x, as like 4. So this kind of polynomials are called as constant polynomial. Constant polynomials, and here the degree of the polynomial, if we are doing it in a variable x, so that's going to be 4x power 0, so the degree will be 0. So whenever the degree of a given polynomial is 0, that polynomial will be considered as a constant polynomial, or a zero polynomial also. Now, what do you mean by zero of a polynomial? Let's study this. What is meant by zeros of a polynomial? A real number k is said to be 0 of a given polynomial p of x if p of k is 0. That is, if we can substitute the value of x by that k and then our polynomial turns out to be 0, then we can consider that real number value k as the 0 of that given polynomial. For example, if we consider one polynomial p of x as x plus 1, now we can see that p of minus 1, if we can find out its value, then it's going to be p of minus 1, that is, in place of x we will be using minus 1. So that's going to be minus 1 plus 1, that is 0. That means p of x is 0 for x equal to minus 1, which means that x equal to minus 1 is a 0 of the given polynomial. Similarly, for another example like p of x equal to x plus 2, and that's going to be like minus 2 plus 2 is equal to 0. So x equal to minus 2 can be a 0 of this given polynomial. Now, depending on the degree of the polynomial, each polynomial will have as many zeros, maximum number of zeros, depending on the degree of the polynomial. That is, for a linear polynomial, that is of degree 1, it can have maximum of 1 0. For a quadratic polynomial that is of degree 2, it can have maximum of 2 zeros. For a cubic polynomial, it can have a maximum of 3 zeros. So here in this video we have studied about basically on the topic degree. How do we recognize and identify the degree of a polynomial, and what are its relationships on how we based on this degree of a polynomial, how we can name different types of polynomials, and how we can identify how many zeros a polynomial can possibly have. So as I repeat again, degree of a polynomial is nothing but the highest power of the variable occurring in the given polynomial, and based on that, when the degree is 1, we call that polynomial as linear polynomial, degree 2 quadratic polynomial, degree 3 cubic, 4 biquadratic. And zeros of a polynomial, as we have all studied in the earlier classes of class 9 and on, it's that real number k which converts the given polynomial to 0 when it is substituted by the value of k. So if the degree of a polynomial is 1, then it can have maximum 1 0. If the degree of the polynomial is 2, it can have maximum of 2 zeros, and degree 3 maximum of 3 zeros, and so on. It will continue. Like if a polynomial is of degree 4, it will have a maximum of 4 zeros, and so on. So in the next upcoming video, we will be basically focusing on quadratic polynomials that will be of degree 2. So we will be seeing the relationships between its coefficients of a quadratic polynomial for 2 zeros. Thank you.